Hi there team, Coach Alexa here. Another video in my series on feet. And what I'm going to talk about today is a little bit about why we have the feet that we do. So we have quite kind of long feet, and a lot of surface area of the bottom of that foot is in contact with the ground when we're stood, walking, running. And that's quite different to four-legged creatures. And it's because we are bipedal, we're two-legged creatures. So the only animals that really have slightly similar feet to us are the other great apes, so chimpanzees, orangutans, etc. And to a slightly smaller extent, monkeys. Monkeys tend to have feet that are a little bit more like hands, a lot more dexterity, much longer toes. So the foot design that we have is very much because we just spend all of our time, pretty much, we're not climbing trees or anything like that, pretty much all of our time is on our feet. So there's a bit of a kind of distribution of that body weight force by having bigger feet, but also they act as part of our propulsion mechanism. So if I think about the back leg of my dog, her knee joint is actually quite tucked up quite far. It almost looks like it's part of her body. It's not like in the middle of a long kind of leg that sort of sticks out from the body like it does with us. And then her heel joint looks like it's actually about halfway, a third or half the way up her leg. And from an anatomy point of view, which I'll cover in my next video, she's almost the equivalent of us being up on our toes. So she's sort of right forward on just the toe bits of her foot. Her heel is much higher up her leg. Now for us, we get a lot more kind of drive and efficiency by having our foot flat on the floor and using some of the tissues in our foot, calf and ankle as propulsion. So if you think about my dog again, her body is this way, so she actually can kick her back legs out quite far behind her when she's really running fast, kind of a gallop or a sprint. So that is her kind of energy propulsion system. We don't have that because our body is upright, right? So there's only so far back that our legs can go. So we rely quite a lot on some cunning little setups in our feet and around our Achilles and calves. So the first of which is that we have an arch in our foot. So that is supported by different tendons and ligaments connecting all of the foot bones together. And also you might have heard of the plantar fascia, because it can call plantar fasciitis, which is when it gets inflamed and irritated. A big sort of arch of connective tissue that sits underneath our arch. So when we land, our body weight and the force coming downwards compresses our foot, and then as our foot leaves the ground, that arch pings back up again, and that produces a little bit of forward push, forward momentum, part of our gait pattern. The other thing that happens, and I'll do this with a sort of upside down proxy as a hand as a leg. So imagine this is the floor. I'm kind of running along the ceiling. I thought it'd be easier than waving my feet at you on camera. So when we land, the ground kind of pushes back our foot. So we flex our ankles, like bringing our toes up towards our shins. We put that ground sort of puts that force through. And then as our leg moves underneath us, comes out behind us to toe off when our foot leaves the ground, that elastic sort of pushback that we've kind of tightened that elastic band down the bottom of the foot and up into the Achilles tendon down here in the calf. And I'm not even moving my hand here. I just let go of that tension and boop, it pings back up. So every time the foot leaves the ground behind us, we've loaded it up, we've stretched it, we've flexed that ankle, we've put we've stretched that elastic band that is our Achilles tendon and our calf complex. The foot leaves the ground behind us, that elastic energy is released and pushes us forwards a little bit more. You'll notice the difference when that system doesn't work as effectively. So if we're running on really soft ground, muddy, sand, particularly challenging, maybe even deeper snow, something like that. So in those conditions, that elastic energy that releases when our foot leaves the ground behind us and gives us that little bit of a boost forwards, it doesn't give us the boost forward, it just gets lost by the foot moving further down into that soft ground. And that's one of the reasons why you notice that running on softer ground is so much harder, because that lovely free elastic energy that we get for each stride just dissipates that bit more quickly. So they're fascinating, our feet, and if you do have, a four-legged creature that you know well, have a bit of a look, where their knees are, where their heels are, and how different they are to the structure of our feet. They're much bigger for our body size, much more kind of complicated in a way, similar, but kind of elongated in different ways, and these additional sort of elasticity structures built in to help propel ourselves for walking and for running. So yeah, look out for the next video where I will have some diagrams and props and tell you a little bit more about what that means for the anatomy of our feet.